Hi friends, in the last video, you got a fair idea about data center layout. Now in this video, let's learn some basics about power. Before we start, let me ask you, what is the main component of your most expensive cell phone? Is it the sound quality, speed, display, memory, or is it something else? The answer is charger. Your charger accepts the electricity as its input, which helps to run your mobile phone and its applications. As you saw, charger is one of the least thought component of the cell phone. Similarly, electricity is one of the least visible elements of your data center. If I ask a CIO or CTO of any organization who are the superstars in your DC, then most probably they will answer that the superstars are the lightning fast servers or the smart CPUs, the enterprise class storages, the memories. But the fact is, servers without electricity is just a heap of metal parts and will be of no use. So it's very important for a person working in data center to know what an power is. Can you tell me how is electricity measured? Is it in amperes, volts, watts? Well, let's see. You must have seen this power socket, right? If you happen to see this socket, if you open this socket, you can see some wires which are connected to it. These wires are then further connected to the main switch. Okay, pardon me for my drawing. So whatever is flowing from these wires is nothing but current. Current is the flow of charge or the moving electrons through the power lines. Now, the devices like this outlet or the circuit breakers, those are measured in amperes. In the sense, if I say that this socket is rated for 15 amperes, what it means is if I happen to connect any device that draws more power than 15 amperes, then there is high chances that this socket will burn out. On the contrary, you can connect any device which draws lesser electric current. You are well aware that if I don't connect any device to this socket, then the power will not run. That means there should be some force or there should be some pressure or there should be some device that draws this current out from the socket, and that force or that pressure is measured in volts. Okay, so basically voltage attempts to make the current flow. Current will flow only if the circuit is complete, right? So for the current to move, there should be some force or push that is applied to that electricity. Basically, voltage is a cause and current is the effect. Many of the household devices we use every day run at 240 volts. If you happen to see this charger, okay, if you happen to read it, you can see that it runs at 240 volts. It is written on that charger that how much volt it runs at. That means if you connect a laptop or any other appliance to this charger, any other supporting appliance to this charger, it will generate a force that will pull that much of electricity, right? Now, if you connect a device which creates a less pressure or a less force, then what will happen? Then it will pull lesser current, correct? So, more the voltage, more the current. Lesser the voltage, lesser the current it pulls. What is watt? Watts is nothing but the actual electrical power consumed by any device. Okay. A heavily loaded server might use 450 to 500 watts. Again, it depends on device to device. It depends on server to server. You are expected to refer the manufacturer's guidelines or the manufacturer's faceplate that is connected on that device before connecting the device in your data center network. You must have seen in used data centers, Watts are often measured in kWh or even megawatts. Now there is a simple formula. Watts equals to volts into amperes. What it means? This means that the amount of power used is equal to the pressure times the current. For example, a server hooked into a 120 volt outlet running at 3.2 amperes would consume how much watts? It's pretty simple. It will consume 384 watts. 120 into 3.2 is nothing but 384 watts. Let me give you one scenario now. There is a server rack which is installed with 20 amperes power strip, and you as a data center person, you have been asked as in how many servers you can plug into that rack. There is one data which is given to you, that is the servers use 280 volts and they consume 400 watts of electricity at the maximum capacity. So task which is given to you is how many servers you can plug into that rack. To make this task simpler, I'll just explain you what exactly the question is. Okay, sorry again, pardon for my, this is, assume this is a rack. Okay, this is a rack in your data center. Okay, this is the front side and this is the back side. Now behind the rack there are some PDUs which are connected. Okay, rack PDUs, and it has got these sockets. Multiple sockets are there. It can be 16 pin, it can be 8 pin, whatever. Okay, like this sockets are there. Now question is, this power strip, okay, it supports 20 amperes. Okay, and there are servers. Let's say this is one of the server, this is one server. Okay, this one server use 2808 volts and they consume 400 watts of power. So the question is, how many such servers can be connected? Is it just one or many such servers can be connected? Understood the question now? So let's move. First, whatever data has been given to you, based on that data, you can definitely find out how much current that server is consuming. So what is the formula that we saw? Earlier formula for power. Okay, just use that formula. So ampere per server will be 400 divided by 208 volt, that comes to 1.92 amperes. Hypothetically, 1.92, let's take a round figure for discussion, it is 2 ampere. So hypothetically you can plug 10 servers in this rack, right? You can connect 10 such servers. However, you shouldn't plug more than 8 for a safer side. 20% should be the buffer. Okay, so if any management person calls you and says, hey, I can see a lot of space in the rack, why don't you simply use it? Why are you wasting that particular space? At that time you can simply answer this, that the rack PDUs are supporting lesser amperes, and that's the reason you cannot connect more than 10 racks or more than 8 servers, sorry, not racks, more than 8 servers in this rack. Now in this same example, let's reduce the voltage the servers use. Okay, instead of 208 volts, do the same calculation using 100 volts. You will find that the current used will be 4 amperes. In that case, 4 amperes means how many servers you can connect? 20 divided by 4, that is you can connect only 5 servers. That means more voltage means it draws lesser current and thus it is more energy efficient. Now that you have understood the basics of power, let me quickly show you how the electricity is generated. The four main components in electricity generation are the power generation plants, the transmission towers, the regional substations, and the local substations. Power generation plants can be on coal or even the nuclear power plants, the hydroelectric power plants. These power plants generate lot of electricity. They generate the electric power which is then transmitted to multiple substations. Using these transmission towers, it is transmitted to the regional substations. These substations have got huge transformers that pull the power from the power generation plants through the transmission towers. Once the power reaches at the regional substation, the local substation further pulls the power from the regional substation. From there, the power is distributed to the data centers or residential buildings, and then it is either distributed using three phase or single phase as per the requirements. Mostly in our data center, the local substation is physically located. All these other three things like power generation, transmission tower, and regional substations are not a part of data centers. So that's it for today's lecture. Thank you for watching.